Hello, all. So, now in the engineering chemistry, we are going to discuss about another case study, that is clean technology development in chemical industries using a zeolite based catalysis. So, we are going to use a catalyst particularly based on the zeolite things. So, zeolite, we know that it's usually used to filter the water, so that can be used to produce a clean technological development in chemical industries. So, with the introduction, clean production and other preventive initiatives such as eco auditing and green technologies are the main measures being used to advance sustainable development in the industrial sectors. Cleaner production could be applied in the chemical industries by using an integrative strategy for environmental protection and pollution prevention. This strategy would need to be focused on processes. The process is particularly the conversion of energy, raw materials, elimination of a toxic compound, and reducing emissions by products and wastes. So, by doing this, we can move on to a sustainable development, which can be defined as a development that meets the need of the present without compromising the future generations. The expected results of a sustainable development in a society where a quality of life and use of natural resources meet human needs without jeopardizing their natural systems. That is, we are going to save something for the future generations without compromise. The three essential development of these sustainable developments are environmental protection, social development, and economic growth. So, in the name of economic growth, we should not compromise our environmental degradation. So, we should not allow the environmental to degrade, and social development should also be encouraged. So, in chemical industries, a clean technology processes have a positive impact on the local, regional, and global issues. The chemical industrial sectors includes the companies that produces industry and certain chemicals. Chemical industries converts raw materials. Oil, the crude oil has been processed and is converted into different things, petroleum, diesel, etc. Natural gases, air, purifying water, metal, mineral processing, etc., which have some 70,000 different products have been used by us in our daily life. So, inorganic chemicals which we use includes ammonia, different fertilizers for the agriculture fields, chlorine, caustic soda of day-to-day life cleaning equipments, acids, nitric, phosphoric, and sulfuric acid in the industries have been regularly used. So, without these acids, no industrial production will occur. The fertilizers, we have an ammonium nitrate, phosphate, and potash chemical fertilizers. The companies manufacturing and marketing the chemical products are given a top priority to protect the environment. For example, we take a PET nitronium Wixart company, a nitrogen fertilizer manufacturing company in Hungary, and a Royal Dutch Shell oil and gas companies. These companies, to decrease the detrimental environmental impacts on air, water, and soil, environmental programs and action have been commenced by most companies, which mostly focus on production technologies and environmental friendly product development so as to maintain or to prevent the environmental degradations. In many cases, the goals of sustainable industrial developments can be realized by catalytic process. So in this catalyst, zeolite have been found promising application in biomass conversion, fuel cells, thermal energy storage, carbon dioxide absorption, air pollution control and wastewater treatments. The chemical industrial companies have been operating in light of the environmental stipulations of an European Union and the requirements to meet the pertaining legal environmental regulations. The pollution impact assessment is usually measured using an index of global pollution, which takes into consideration quality indicators for the main environmental companies like air, water, and soil. Nitrogen oxide emissions, so particularly NO2 and N2O, are considered to be the major pollutants in the atmosphere and results in acid rain, photochemical smog, and ozone accumulation, that is, ground level ozone accumulations. Furthermore, these oxides are corrosive and hazardous to the health. Similarly, to be an European Union statistics, the main anthropogenic, that is man-made nitrogen oxide sources in Hungary are the public electricity and the heat sectors 43%, transportation 44%, agriculture 10%, industrial process 2%. So the emission limit for nitrogen oxides, particularly NO2, is 350 milligram per liter, that is per meter cube, in dry tail gases of 0 degrees Celsius and 101.3 kilopascal in the case of nitric acid productions. So this emission limit, it's found to be somewhat higher. So nitrogen oxide emissions. The sources of nitrogen oxides are combustion of a fuel, that is, we are burning some fuels, nitric acid production in fertilizer manufacturing technologies have been used for nitrate fertilizers, metal finishing operations, we used more nitric acids, chemical processing such as we are producing explosive, plastic, nitrated materials, etc. In agricultural, that is biochemical processes resulting in the generation of nitric acid in the soil and production of nitrates by rhizobium bacteria, which is present in the roots of the leguminous plants, and that is nitrification or denitrification, that is conversion of a nitrate into a consumable nitrogen by plants, decomposition of a nitrogen compounds from the living stock, manures, and dead animals. So what is catalytic test, and now how the catalysts have been used to remove the nitrogen? The practical realization of a clean technology is a possible solution for the present air pollution problems, particularly to reduce the nitrogen oxides, NO, NO2, NO2 discharges from the industrial process. Regarding the removal of nitrogen oxide, the selective catalytic reduction, SCR, and non-selective catalytic reduction, NSCR, can be taken into consideration by using catalytic converters on automobiles. Mobile NOx emissions have been drastically decreased in gasolines and diesel operating vehicles. So improvements regarding the reduction of this nitrogen oxide emission can be realized by the devising an efficient catalyst for an decomposition of NOx and N2O. So we have to find out an best available technology, or a tail gas treatment of nitrogen oxide production is based on SCR and NSCR processes. The following chemical reaction can be gassed as tail gas treatment, that is NO and ammonia with oxygen produce nitrogen and water, and NO2 and ammonia will produce nitrogen and water. So during this SCR, and the NOx containing gases are introduced into the reactor and are mixed with ammonia. The process is the NOx, that is NO or NO2, are mixed with ammonia. With the reaction, we produce nitrogen and water. This is one SCR technology. A typical SCR industrial catalyst is vanadium pentoxide and titanium oxide. We can use a vanadium pentoxide or titanium oxide and a zeolite based catalyst. So instead of using V2O5 and TiO2, zeolite is a natural product that can produce a very good results. The ZSM5, the zeolite size of 5 catalysts are widely used in the addition to the denitrification of NOx process. In petroleum processing industries, a fluid catalytic cracking and hydroisomerization, etc., we use many catalysts. So those catalysts are not efficient in removing these things. So in the exhaust level, we can use the zeolites. The outcome of the denitrification of NOx, DNOx process is the conversion of NOx gas into N2, that is nitrogen gas and water vapor. As we saw the reaction before, so what we did here, NO and NO2 combined with ammonia, we formed into an NO2, N2 and water. The same way, so DNOx is a process in which the NOx compounds are converted to nitrogen and water. Okay, so which released into the atmosphere. So in this study of SCR of NOx, we studied of eliminating the detrimental pollution discharges from the tail gas, particularly the nitric acid from the plant. So the conventional method of we are using vanadium pentoxide and titanium oxides and ZSM5 catalysts have been studied, and it is to be noted that the both catalysts are not recommended to use below 230 degrees Celsius. So at low temperatures, the ammonia reacts with NO2, resulting in the ammonium nitrate and leading to the clogging. So considering zeolites are moderately high, used particularly in high temperatures. So above 230, the vanadium pentoxides are not able to be used, but zeolites can moderately work at high temperatures, that is high temperature operating catalysts. They are stable up to 600 degrees Celsius and are more environmentally friendly since higher conversion can be achieved at the same reaction temperature, and no toxic elements such as vanadium can enter into the atmosphere. The recommended operation temperature range of the use commercial FeZSM5 catalyst for DNOx is between 200 to 520 degrees Celsius with an optimum decomposition temperature of both nitrogen oxides and dinitrogen oxides around 420 degrees Celsius. The conversion rate is exactly close to 98%. That's a good results in it. So on the basis of the time on stream experiments, it can be stated that the zeolite based catalysts can be used for a longer period of time, for the longer weeks, 1 week without the significant activity loss, and can also we go for a high temperatures around 600 degrees Celsius. Based on the experiments carried out, it can be concluded that technological developments could significantly contribute to reduction in the environmental pollution and the greenhouse gas discharges in the industrial facilities. So, coming to the conclusion, the natural zeolites and synthetic zeolites. So, here, what is natural zeolite? Natural zeolite is a geolitic material which we can get in nature, like a mud. It's called as a green mud. It is a form of silicates combined with the nitrogen, sodium silicates. It is a silicates of sodium something. And what about synthetic zeolite? So, sodium, the natural zeolites are non-porous in nature. So, to improve the porosity and to increase the pore sizes and to develop the absorption activities, and we can go for a synthetic zeolites. So it can be efficiently used in several chemical processes, including the applications. Suitable production and consumption are important issues. That is, in 21st century, since human society is faced with decreasing availability of natural resources like energy carriers, clean water, and depletion of soil. So by using these natural things would give an efficient ideas. So a special attention should be paid to preserve the environment, to mitigate environmental pollutions, and to finding new possible alternative routes to the substrate, a fraction of the fuel demanded with a renewable and an inexpensive energy carriers. So this study represented two cases in favor of clean technology with application in chemical industries with an objective of contributing to implementation of the goals of sustainable development. One is it aimed to decrease the detrimental emission of nitric acid production. So first we are trying to decrease the nitric acid productions or the NOx, any form, NO or N2O or NO2, anything which because it's contribute to acid rain, it creates some breathing difficulties and it has effects to the materials, so on. The second in this case study dealt with the use of waste vegetable oil as a secondary raw material to produce biodiesel, making possible an important economy for diesel production. So in that there will be a reduction in NOx. So this can also be taken into an account, so that in order to reduce our pollution levels. So with this we can go for references in the sustainable development environment given by Gerald Singh, Haraj and et al. Calcium carbonate crystal growth with morphologies of residual clarines used as zeolites, Navoti et al. Towards a global sustainable things. So thank you. You can also go for these references, because zeolite is basically a natural material, have a wide area of research in water treatment to convert some hot water into soft waters, like that. So it can also be used to reduce the emission levels.